In XSI, the lattice is one of the most powerful deformers. Here I have a simple 2x2 polymesh grid. If I were to apply the lattice with the object selected, it automatically gets bound to it. If I were to reduce a number here and start to manipulate some of the points, I can go through some of the properties. By default it does a 4x4x4 subdivision. I'm now going to hold down Control and just snap to this point here. We currently have a linear interpolation, so we can see how the fall off is occurring. If I were to change this to curve, we get the idea of how it's deforming across the lattice itself. So it will give a slightly smoother profile and interpolate across multiple points. The lattice itself, when the object is selected, automatically gets parented underneath the object. This is such that when I now move the object, it will follow. If I were to delete this lattice, if I don't have the object selected and I ask for a lattice, it gets a predefined size, and this is the standard default. So the majority of the times, if I were to do something like 1x1x1, oops, and maybe 2x2, now if I start moving some points around, absolutely nothing happens. This is because the lattice has not been bound to the object. With the grid selected, I would actually go inside my deformers and say deform by the lattice, and then it'll give me a picking session and I pick the lattice like so. Now when I manipulate the points on the lattice, there we go, it's doing its deforming. If I were to use something like the sphere here, lattices give an amazing amount of control over not only modelling but also animation deforms. With my object selected, when I apply the lattice, it automatically applies the deformation and puts the lattice as a child of the object. By default, you can see the subdivisions. So I'll just put like 2x2x2. The pre-deform size is relative to the transformation size, as well as, in this case, the bounding box of my object. So if I were to do something like scale this, and now apply a lattice again, oops, don't need that, primitive lattice. The predeform size says it's still 4. That's because my object has an offset in the scaling value. If I were to say 0.5 like so, it's still looking at the pre-deform size. So deleting this and hitting, I'm just going to hit the free scaling, now means that it's 1x1x1. Now when I apply the lattice, there we go, it's relative to that size. So it's looking at the unit size here relative to the SRT. Just going to put this back to 222. The first thing is, if I were to make it 1x1, it's a very useful way of doing things like proportional modelling. So here I have the proportions without having to resort to things like grabbing my single point here, turning proportional on, changing the radius like so. Very quick and easy way to do that type of proportional modelling. You notice it goes back to its default values. This is set inside the property pages of the object here, as you can see. What happens though when we have things like a primitive or an operator is underneath the application, the scene defaults, here it's already placed a lattice. So now if I were to go into here and say let's make this 2x2 and make it always curved, now when I get my lattice, there we go, it's looking at that primitive default. It only uses the subdivisions, as if I were to now get it without anything selected. There we go, I'm now defining the defaults. It's because the selected geometry controls the lattice. When I do a simple deform of my lattice, and here perhaps some scaling, we have a number of controls. The first is if I were to select my sphere and move it, because the lattice is a child of the object, then it moves with it. I could use things like child compensation and keep the lattice where it is. I could also cut the lattice from underneath the object and have the same effect. So when I move my, there we go, when I move my object, my lattice stays where it is. I could also now move my lattice and it deforms as well. It's a slightly odd deform here, so let's have a look at what's controlling it. Underneath the operator for the object is a lattice deformation. Now this is the default, which is all points of the lattice. This is the old SI3D style. That means that when I, let's say, move my lattice here, I'm just going to turn on my manipulators. Is that as I move my lattice, it's still being deformed relative to the position of the lattice. If we were to switch that to say fall off relative to the bounding box, is that only when it's coming in contact will it deform. If I were to go with a pre-deformed bounding box, that is, it's going to stay as it was before I applied the deformed lattice. If it were the deformed bounding box, you notice the difference there. So a lot of the time you'll want the pre-deformed bounding box relative to fall off lattice here. So you can see the difference. So move this back down. Now for scaling, if I were to scale my lattice, it doesn't make any effect. If I were to treat it as a deformer, there we go, it also works like so. So apply the scaling to the geometry, similar to the SI3D here. The fall off profile controls through the start and end, just like any other profile, and then I can even change and edit the profile like so. You see, it gives me a bit more control. Working with a predefined box for my lattice means that if I have no object selected and then I apply my lattice, I still can control the deform size that I wish. It's a simple matter of then selecting my object and saying deform by lattice, and then it gives me a picking session, and there we go. I'll treat this scaling as deformation, so now I can use, it's a funky way of doing that. It doesn't apply it as a child of the object, rather it's the scene root here, so it gives me a bit of control like so. It also means that if I were to remove this deformer, I can apply it relative to components. Anything can be deformed when it's a component, just in the same way an object can. If I were to tag some points here, maybe grow this selection, if I were to simply, with the object component selected, get a lattice, it might not be exactly oriented correctly because of the scaling and rotation factors. That's not too much of a problem, because I can, while the object, when I grab the lattice object, I can simply rotate the deform box like so, and actually orient it to how I want. If I had tagged all the points and then oriented it, I'd get a very different effect, because it's doing the deformation on the points. So sometimes when you apply a lattice to components, you can simply orient it with the object selected like so, and then start to define, there we go, how you want it to deform. Having a predefined box is exactly similar, whereas you're going to do the orientation first, then take the points, and then deform, in this case by the lattice, like so. Doing it that way, you can see though that the operators will automatically apply if it has things like scaling or a deformed bounding box like so. But it does give me the correct orientation that I wish. I can always apply another operator on top of the lattice as well, or even put another lattice on top of that lattice. There we go. And now I've got a 1x1 box which is controlling the lattice underneath, which is controlling the object underneath.